This video is on exercise 1B of A-Level Further Maths Core 1 textbook. So this exercise is all about solving equations that have complex roots. So it's very interesting because we have been told that whenever the discriminant of an equation is negative, that means the equation doesn't have real roots. And now we want to see, okay, so it doesn't have real roots, but does it have any other roots? And the answer is yes, it has complex roots. Now we are at a position that we should learn how to solve such equations and also get the correct answers, which is very easy, by the way, so don't think it's something very difficult. Let's just start with the first one. Z squared plus 121 is equal to 0. So as usual, let's rearrange the equation and we take away 121 from both sides. So we get z squared is equal to minus 121. So we haven't done this before, but now when we are doing questions in the and when we are working with complex numbers, then we are allowed to take the square root of negative numbers. So in this case, let's take the square root of both sides. So you can imagine this case that we have seen a lot while we were working with real numbers. X squared plus is equal to 25, and then you take the square root of x and you will have plus or minus 5 as your roots. This is exactly the same thing. So let's do that. We take the square root of both sides, and on the left hand side we will have a square root of minus 121. Now in the previous section we learned how to write such square roots in terms of I. So this can be written as, because this can be written as 121 times minus 1, because that's one of the roots that we are always allowed to use when we are working with surds. And we know that we can split these, so we can rewrite this as root 121 times root minus 1. So hopefully you can remember that. Root 121 times root minus 1, and root minus 1 is just I. And I should say that I should have written plus or minus this. Yeah, I just forgot that. Plus or minus, plus or minus. And now we can simply take the square root of 121 and we are done with the question. So root 121 is 11, but that's plus or minus 11i. So this is the answer of this equation, of equation A. As you can see, the general process is very similar to what we have been doing since high school, but the only difference is that we should be able to write in terms of I, because if you write the number in terms of I, then everything gets very simple. So let's do more questions so you can see what's going on. B, z squared plus 40 is equal to 0. So take away 40 from both sides and we get z squared is minus 40. Now we can take the square root of both sides, so we have z is equal to plus or minus root 40. So in the previous question I just did everything and I included each step, but you can skip some of them because you can just do some of them in your head instead of just writing root. For example, root minus 40 can be written as root 40 times root minus 1, then root 40 times I. You can straight away just rewrite this as z is equal to plus or minus root 40i. So you can do this, or whichever works for you, because now you're at the earliest stage of learning how to work with these equations, so you can write each step so you can see what's going on and you can follow. And now so the thing is here that we can write 40 as 4 times 10 and I, and 4 has because the square root of 4 is 2, so we can have plus or minus 2 root 10I. Or we can write this in this way as well. Both of these are equal, by the way. Some people prefer to write plus or minus 2I root 10. Just, writing the I unit in different place. And yeah, so that's it. This is the answer of the question, and just up to you, whichever way you want to write. C, 2z squared plus 120 is 0. So take away 120, and we get 2z squared is minus 120. Let's divide by 2. Z squared is minus 60. Now take the square root. Z is equal to plus or minus root minus 60, but we can write this as plus or minus root 60I by just splitting the square roots. And so we can write 60 as 4 times 15I, and we know that the square root of 4 is 2, so that we get Z is equal to plus or minus 2I root 15. And this is the final answer. So we have two roots, basically two complex roots. One is 2I root 15, the other one is minus 2I root 15. D, 3z squared plus 150 is 38 minus, is equal to 38 minus z squared. So let's add z squared to both sides, so we can get rid of the z squared on the minus z squared on the right hand side. We get 4z squared plus 150 is equal to 38. Now take away 150 from both sides. 4z squared is equal to minus 112. Dividing both sides by 4, z squared is equal to minus 28. Let's take the square root of both sides. Z is equal to plus or minus root minus 28. And Z can be written as plus or minus root 28I. And we can write 28 as 4 times 7I, and 4, the square root of 4 is 2, so we get plus or minus 2 root 7I. E, z squared plus 30 is equal to minus 3z squared minus 66. So let's add 3z squared to both sides, so we get 4z squared plus 30 is equal to minus 66. Take away 30 from both sides. 4z squared is equal to minus 96. Divide 4. So let's divide both sides by 4. Z squared is minus 24. Now taking the square root of both sides, z is equal to plus or minus root minus 24. And we can write this as plus or minus root 24I. And we know that 24 is 4 times 6I. And the square root of 4 is 2. So the answer is plus or minus 2 root 6I. F, 6z squared plus 1 is equal to 2z squared. So let's take away 2z squared from both sides, and we get 4z squared plus 1 is equal to 0. Now take away 1 from both sides. 4z squared is equal to minus 1. Divide 4 from both sides. Z squared is minus 1 over 4. Let's take the square root of both sides. Z is equal to plus or minus root minus 1 over 4. And we know that square root of minus 1 over 4 can be written in this form, 1 over 4I, because root minus 1 is I. And now fortunately we can take the square root of 1 over 4 without any any special thing to do here, because square root of 1/4 is just a half. So the answer is plus or minus a half I. So that's it. Thank you for watching. Make sure to subscribe for more videos. Good luck.